Welcome to Spring LIB.
Let's start with the set of positive integers greater or equal than 10. This set is countable, and in fact we have the bijection s into z plus given by n mapped to n minus 9. And that's because the set S contains the elements 10, 11, 12 going up, and when we subtract 9 we get 1, 2, 3 going up, which is z plus. Now for case B, we have the set of negative odd integers. We observe that we can write a generic negative odd integer n as minus 2m minus 1, where m is a positive integer. And therefore we just have the bijection s goes into z plus, where n goes to m, and of course we can obtain m by just 1 minus n divided by 2. Now for C, we have the set of integers which are in absolute value lower than a million. This set is of course finite because it contains the element minus 999, minus 99998, all the way up to 0, and then all the way up to 999999. And of course this is a finite set with 2 million elements roughly, but it's finite. Now for D, we have the set of real numbers between 0 and 2. Now we observe that we have a bijection from S into the interval 0, 1, given by x goes to x half. But now the set 0, 1, the interval 0, 1, is uncountable by Cantor's diagonal reasoning, and therefore also S is uncountable. Now for E, we have the set S given by the Cartesian product A times Z plus, where A is the set containing 2 and 3. So again, the trick here is to divide half of the set S that goes to, let's say, the even numbers, and the other half of S that goes to the odd numbers. So we have a map that goes from S to Z plus, where we map the elements 2n to, let's say, twice n, and the elements 3n to 2n minus 1. And therefore the set S is countable. And finally, for F, we have the set of multiples of 10 with sign. So again, we want to split the set S into two subsets and assign one to the even numbers and one to the odd numbers. So first of all, observe that n can be written as 10m, and the deal is that m is now an integer number with sign, so we will need to split between positive and negative m's. So let's write the bijection. S goes into z plus, where n goes to two minus m divided by 10 plus 1 if n is lower or equal than 0. So if n is either 0, minus 10, minus 20, minus 30, what we get is minus n divided by 10 becomes just this number m, which is 0, minus 1, minus 2. Then when we place the minus in front, becomes 0, 1, 2. So we multiply that by 2 and we add 1. So this first branch here is sending the elements 0, minus 10, minus 20, minus 30 to all the odd numbers, so 1, 3, 5, and so forth. And now for the remaining half of the set S, we just map n to twice and tenth if n is greater than 0. So n is 10, 20, 30, n divided by 10 is 1, 2, 3, and we multiply it by 2, we get all the even numbers. So F is a bijection, and therefore S is a countable.